All right, today I'll be going over how to identify if a compound has an E or a Z double bond. So to identify if a compound has an E or a Z double bond, you first need to assign priorities to that double bond. So if we look at the left carbon in the double bond, we see that it's attached to a carbon and a hydrogen. The carbon is heavier, so it's going to have a higher priority. So this carbon, the CH3, has higher priority than the H. If we look towards the other carbon, the first things it's attached to are both carbons. So that means we got to go to the next layer to see if there's to see which one has priority. And if we go to the next layer, let's look at Ca, all we have is hydrogens. But if we look at Cb, we see that there's a carbon, that the Cb is attached to a carbon and two hydrogens. So a carbon and two hydrogens is heavier than three hydrogens, so that is where we assign the higher priority. So in this instance, we have a Z double bond. Additionally, if you have multiple bonds, like a carbon double bonded to an oxygen, this is going to count as a carbon like single bonded to two oxygens. So you'd count the oxygen twice. So if a tau results after the first atom, go to the next, each time following the highest atomic number. Keep moving until an assignment of E or Z is made. As you can see by the example, the carbon double bond to the oxygen counts twice when assigning priorities. So that's why this side has higher priority than this side. So in this case, we'd have an E compound because over here, the carbon's higher than the hydrogen. And over here, this carbon double bond to the oxygen gives priority over this compound, where it's just single bonded to the oxygen. So here are some examples. Here we can't assign a priority here because we have the same bonding arrangement coming off of each double bond. So here we have neither E or Z. Same applies to here, where on this double bond we have two H's coming off. So you have to be able to assign priority. If you can't assign a priority, you can't be E or Z. Same here. Here we have a Z compound because we have a hydrogen coming off here and a carbon coming off here. Here we have a carbon coming here and then H coming off here, so that's a Z compound. Here, once again, we have a hydrogen over here and a carbon over here, hydrogen over here, carbon over here. And here again we have an E compound where the carbon's over here, hydrogen's over here, carbon's here, hydrogen's here. Another thing I wanted to add is it's the first difference you see. So like even though this compound looks like there's more weight on this side, it's the first difference. So here you have a carbon, and then if you look beyond that, you have two hydrogens and a carbon. Here we have a carbon, and if you look beyond that, we have two hydrogens and an oxygen. This carbon, there's this oxygen and two hydrogens off the carbon beats this carbon and two hydrogens, even though it's longer and a bigger on this side, so it would still be a Z compound. Same with over here, the first difference is that chlorine. So even though this side is bigger, the chlorine still has priority. That's why this is an E compound. And this example is pretty self-explanatory. I think we went over that. And here, it's the same thing as before. I also want to go over that if you have a triple bond, you can't be assigned E or Z either. Only double bonds can be assigned E or Z. And yeah, this is another example of it's the first priority. So even though this side looks bigger, this side you see the first difference. So you see it's first attached to a carbon. We move on to the next layer. We have two carbons and a hydrogen. Here we have a carbon and two hydrogens. So this side wins because it's attached to two carbons and a hydrogen rather than just one carbon and two hydrogens.